Today's topic is field effect transistor, also called junction field effect transistor. So, what is FET? Actually, we consider a N-type bar, which is the semiconductor which is topped with pentavalent impurities. And if a potential is applied across the bar, the end where the negative potential is connected, it is called source. The end where there is a positive, it is called the drain. The electron will move from source to drain, and the current will be measured by a milliampere meter. And along the side, at the middle, the bar is topped with trivalent impurities. That becomes the p-type semiconductor all along, and the p's, they are connected together. The p form a gate. It is given a name gate because the electron which move from source to drain have to pass through the gate. The gate can be opened or closed by a potential, which is called the gate source potential. And because the N-type bar and the P-type gate, the p-n junction is formed. This junction formed is not symmetrical, it is asymmetrical. It is like a wedge shaped. It is like wedge shaped. This is VGS, that is VST. So between the gate, there is a channel. Between the gate, the current has to pass, the electron has to pass, and gate can be open or closed by applying a gate potential. If the gate is given a negative potential because gate is of p-type, if p-type is given a negative voltage, gate will closed. The gate will closed by giving a negative potential to the p-type gate. So the bar is actually a resistor, and if the potential is here 20 volt, okay, let the potential is 20 volt, the 10 positive volt will be here, 10 plus 8 plus 5 plus 3 minus 2, 0, minus 2, minus 4, minus 6, minus 8, minus 10. All potential will be distributed. The N-type bar, and on an N-type, if the positive potential is on an N-type, become the reverse biased. So what happened? The positive potential on N-type means the reverse biasing. There is more reverse biasing towards the right hand side of the bar. So that's why it is more bulky. It is more along the right hand side. The junction is more along the right hand side as compared to the left hand side. So that's why it is unsymmetrical. It is wedge shaped like this. And remember, the gate can be open or closed, and current has to cross through the gate. If the gate is given a negative potential, it will become closed. It will become more closed, and the current will decrease. If the gate is at less negative potential, the gate will be somewhat open and there will be more current. Gate current the gate, the current, drain current is a function of the gate source voltage and the drain source voltage both. But the gate effect is more than the, drain source voltage. So, the three-dimensional view of the FET is as shown. Here, this is N-channel FET, source, drain, and the gate. Gate is of P-type, and the connection is at here for the gate. Again, the view is shown here, like this is N-channel FET, this is source terminal, drain terminal, and the gate. Gate is of P-type. When we apply some potential at here, that this is source and drain to positive, negative, positive, negative, like this. If we apply this potential, the electron will start moving from source to drain. Like that, here it is a P-channel FET. P-channel, here is a source, drain, and the channel is of P-type, but the gate is made up of the N-type semiconductor. This is P-channel, source, drain, but the gate is made up of N-type semiconductor. In P-channel FET, the semiconductor channel, the channel is P-type, gate is N-type. In N-channel FET, the channel is N-type semiconductor and gate is P-type. Okay. Now here again, this is N-channel FET. This is N-type semiconductor, the red one, and this is, here this is P, this is P, this is a gate, and the source terminal, drain terminal, and the gate terminal. Again the three-dimensional view, source, drain, and the gate. Gate is all around the bar. This is a symbol for N-channel, like this is the source, drain, and the gate. If N-channel, the arrow is inward. For the P-channel, like this is the source, this is the drain, and the gate arrow is outward. If the gate arrow is outward, it is P channel. If it is inward, it is N channel. Now here, like this is N channel, source, drain and gate. Gate is given because gate is P type. Okay, P type is given a negative potential with respect to the source, because source is grounded. So gate is made reverse biased with the help of this battery. The gate is reverse biased with the help of this battery. There will be no gate current. The drain is made, the drain is made positive. This is positive with respect to the source. That is, drain is positive with respect to the source. Electron will move source to drain, but the conventional current will be drain to source, as shown here. This is conventional current. Electron will move source to drain. This battery will measure what is the voltage between source and drain. This battery will measure, this voltmeter will measure the voltage between drain and source. This voltmeter will measure the voltage between, gate and source. There are two voltmeters, this one and this one. Two voltages and one current. Okay, and the characteristics will be between this and this, keeping this constant. Then the characteristics mean the graph between this and keeping this one constant. So there will be the two characteristics curve. The first of all, drain characteristics. This is a graph between what? Here this will be constant. We vary the voltage and we will measure current. Okay, the graph is like this. If the gate is given no potential, the graph is like this. If the gate is given no potential, you are varying what? VDC. You are measuring what? ID. So the graph is like this. This is ohmic region. This is saturation region. This is cutoff region. Now you change gate source voltage -1. Then the ohmic region will be like this. Then saturation region will be like this. And the breakdown region will be like this. This is breakdown region. If you make a gate more negative, ohmic region, saturation region, then the breakdown region. You make gate more negative, ohmic region, saturation region, and the breakdown region. One thing you please notice, the breakdown at 0 gate voltage, breakdown is here. At gate source some negative, it is here. More negative, it is here. More negative, it is here. So the breakdown voltage shift it towards this side by making gate more and more negative. So first of all, saturation region. It is that portion of the graph when ID remains constant and does not change with the change in VDC. Like this is not changing, the current is not changing, current is not changing, current is not changing. Ohmic region, the drain current variation, drain to source with this, the ohmic region. And JFET, it is said to operating as a voltage variable resistance in the ohmic region. The resistance offered by the JFET decreases with decrease the value of negative gate to the source bias voltage. Okay, the resistance offered by JFET decreases with the decrease in the value of negative gate to source bias voltage. So like when the gate source voltage is 0, this ohmic region, here the linear region between the graph, between the voltage and the current, and this portion, this reduces if we are making gate more and more negative. Like it is -3, it is like this, -2, this region is more, this is higher, and -1 still more higher, like this. Moreover, the slope, slope is also increasing with gate source voltage as it increases, mean less negative. So here it is more negative, less slope. So slope is increasing, okay. The resistance offered by the JFET, decreases with the decrease in the value of negative gate to source bias voltage. Decrease in the value of negative mean as like we are going -3 to 0, the slope is increasing and the conduction increases too. Conduction increases mean resistance is decreasing. So FT acts as a variable resistor. In this portion, it is a variable resistor whose resistance depends upon the the gate source voltage. Now, what is the pinch of voltage? What is the pinch of voltage? It's the maximum drain current. That is pinch off. Pinch off mean like that at here. At here what happen? You are increasing VDS, but drain current is not increasing, it is constant. So at this voltage, it is called pinched off. At this voltage, it is called pinched off because the drain current is not increasing. It becomes constant. So this is pinched off. This is pinched off. This is pinched off. So pinched off mean from where after the drain current becomes constant. That point is called pinched off. So now FET breakdown. When FET is operating in saturation region, ID does not changes with drain source voltage up to the certain value. If this is increased further beyond this value, the gate channel junction breaks down due to avalanche effect and drain current shoots up suddenly. Like that, you just look here. This is breakdown, this is breakdown, this is breakdown, and this is breakdown. This can damage the device. The value of the breakdown voltage does not remain constant. It decreases with the increase in negative value of the VGS. So it decreases. Like look, this breakdown is here, it is here, it is here, it is here. Why? The gate source voltage is becoming more negative. So the breakdown shifted towards this side with more and more gate source voltage. The operation of the breakdown region should be avoided so to protect the JFET. In saturation region, drain current remain constant irrespective of the drain source voltage. Now we coming the transfer characteristics. Now what we are doing, like that at here, we gone increasing gate voltage, and when the gate was 0, the current is IDSS. When you are making gate more and more negative, then what happen? Drain current starts decreasing like this. Ultimately, at certain gate source voltage, the drain current totally becomes 0. That is called again the pinch off voltage. Alright? So when the gate source voltage is 0, ID is equals to this much. When gate source voltage is -4, the drain current is 0. So they are the two extreme points on the characteristics, this one and this one. The transfer characteristics grow exponentially with the reduction in the value of the gate source voltage. So at this point the drain current becomes 0. So this is, this is gate source voltage, that it is called the off, like drain current becomes 0. This voltage is called the pinch off voltage,